Hello guys, welcome back again. During our last video, we discussed about testing of capacitors. Today, I'd like us to focus on the inductors or the coils. Yes, if you hear inductor or the coil, it means one and the same thing. So before we continue, I'd like to request you, in case you haven't subscribed to this channel, please, I'm still requesting you, please subscribe guys. Share with your friends who are interested in learning about laptop repair, because we shall be sharing a lot of content about the laptops. So, be it the tutorials, that is the theory side, or the practical, we shall be discussing all of them. So, for you not to miss either of those, we are requesting you please subscribe. Again, we do laptop repairs. In case you have a problem with your computer, you're also welcome. You can bring it to us. So, let's go directly to the discussion of today. Before we proceed, you should be able to identify the inductors within the laptop motherboard. Yes. So first of all, I will be explaining to you what are the types of inductors within the laptop motherboard, and how we shall be testing them, whether they are shorted. However, there's no way an inductor can short, but the power line, it can short that line of which the inductor is soldered along the line. So we shall be testing how to test them, whether that line is shorted or not. And we shall also test the inductors when they are faulty. That is, maybe it's an open inductor, like a fuse. A fuse can be open. That means one point of the fuse is not connected to the other point. So first of all, let's have identification of the inductors within the motherboard. Here with me, I have a motherboard for 1030G. This is 1030G4. Yes, I'm going to explain to you, or I'm going to show you what are the types of inductors which are found within the motherboard. You have two types majorly. One, we have what's called stacked inductor. Stacked inductors are this kind of inductors which are like, I don't know which shape is this. Yes. So these are what's called stacked inductor. You have the bigger ones like this one, you have smaller ones. And in fact, even there you have very small like this one. There's a very small types of this a very small stacked inductor. Not only this one, we can also have a very tiny one. Sometimes you find that there's a very tiniest one. I don't know whether I have any motherboard which contains that small tiny stacked inductor. Just give me a second. Let me check whether I have here. Don't worry. In case I get one here, I'll show you. So I am not keeping for myself, or I am not looking it to see for my own. So yeah, I believe this one, yeah. So I don't know whether you can get this. I know this motherboard is a very old one. However, there's a very small inductor here. I don't know how I'll zoom it in. Let me just bring it this way. You can see this one, the one I pointed to my tweezer. Yes, that's a stacked inductor. A very small one. Yes. So and there are others which are very tiny than that. So so we have the stacked inductor. An inductor is just a wire. So stacked means we have a wire which is one end of the wire is soldered here at this particular point. As you can see, this one side of the inductor is a solder. So we have a wire soldered here. But I don't know which I can try to use this one. This is a bigger one, though this one is a flat one, somehow flat. So inside this material, there's a wire coiled inside, where one end of that wire is soldered here and another end is soldered at the other side. So we can have a look at this a big stack here. I don't know whether this one have it. Yes, even you can see this. You can see this. I don't know how I'll place it. You can see at this particular point, there is a solder on that side. So one end of the wire, which is coiled inside here, is soldered at this particular point, and another one is soldered at this particular point at this other side. Yes. Apart from stacked inductor, we have other type of inductor called thin film inductor. You have a thin film inductor, still a wire, which is the, however, this one is a very straight one and a short one. So that thin film inductor is like a ceramic capacitor. However, it's just a short one. It's not coiled. I believe you can see these tiny components here. Let me just show you with a bigger one. Just here with me, I have a thin film inductor, which is big. As you can see, at this connector of the battery here, you have a very plug component, which is soldered this side and this other side is soldered. So in between the 2 points, we have a wire running inside this component. That wire, that is now what's called thin film inductor. Yes, here is another one. You can see this one. Yes, this one is soldered at this particular point, and the other point. They are like fuse. However, the inductors are more stronger than the fuses, right? So I believe so far at least you've known the types of inductors which are found within the laptop motherboard. Let's have a look at how to test them. How do you test uh, the inductor? First of all, I want you to understand that an inductor is like a bridge. Yes, it bridges the power line. Along the power line, you'll have a section whereby there's been there's a border or there's a cap. Yes, so between that cap, between one particular point of that cap and the other point, you will have an inductor placed there so that it can regulate the voltage flowing past there. That's why the main role of the inductor is to regulate the power or to regulate the voltage flow along the power line. I was thinking maybe I can see one of the inductors or the empty space where could have been an inductor, but I am not seeing any. All right, all right, all right. Here's one. Here's one. So in this motherboard, this is a space where an inductor could have been placed, and this one, and even this one. So an inductor, no, this one's for the capacitor. This one is for the chemical capacitor. So this place we will have had PLV2. We will have had so this one is capacitor. So here, this is the only place where we will have had an inductor, stacked inductor. So at this particular point, there is a cap between this point and this other point. That's why a wire is placed, and that wire is coiled. Then it is covered by a certain material, which I don't even know which type of that material. Then that wire is coiled here. Then another point is soldered here. The other point is soldered to the other point. Right? Yes. So that is inductor. To test them, to test whether the inductor is good, have your meter, have your digital multimeter, turn your meter on, that is to continuity mode, because you want to test the continuation of the inductor from one particular point to the other. Yes. Once you have your meter, yes, you can see my meter is on. Yes, I confirm the baseline of my meter. The baseline should be 0.0. That is 0.0. So it means there's a continuity between one particular point to the other. So this thing inductors, you need when you place the probe against the side of the inductors, it should less zero resistance or it should be 0.0 like that. So it means that wire inside this material thing is continuous. So when you see this continuous, it means that inductor is good. You can see. Sorry for that. You can see 0.0. What about this big one? This big one. Let me just place it this one. This big inductor here 0.0. Yes. So meaning that inductor is good. Yes. And in fact, it's rare for this inductor. This stacked inductor. It cannot get broken or it cannot get open. It's very hard. not unless one point of the inductor is not soldered. Not unless one point of this stacked inductor is not soldered properly. Maybe it's not it's not connected to the way it's supposed to be soldered. Yes, if this end is loose, that's when you can have disconnection between the motherboard and that end of that inductor. What about this small inductor? You can try this one, this very small one. Still, we have continued. So it means that one is good. So let's have a look at these thin film inductors. The same thing we should have the same results, the same testing. Maybe we can start with one of them. We can start with one of them. So this is a thin film inductor. So I want to place it this way so that we shall be able to see. Let me place my meter that side. Then here, let's have a look at here, this side and this side. You can see, yes, you have 0 resistance. So it means that inductor is good, very good. You can see, yes, all of them are good. Yes, it's rare. You can see this one. Let's have a test. Let's look at this one. So let me press it this way so that it can be visible to all. This is inductor 0 0 0 0 0 0 0. They are very good, right? Yes. Maybe as you can see, the shape of this vent film inductor is like that of a ceramic capacitor. It's like this one. However, the difference is the color. As you can see, the color of this one is somehow gray. I don't know, man, we are all always colorblind. So in fact, I don't know which color is this. I don't know whether it is gray or black. However, it is different from this one. This one is, I don't know which color is this. Is it beige or yellow? Yes. So capacitors are beige or yellow in color. However, the inductors can either be green or black. So let's have a look at this another thin film inductor from this particular motherboard. There is I haven't opened this one. So we might have a bigger inductor like this one. For example, this one here, there's this inductor in between the battery connector and the first switch, the first MOSFET of the power. You can see this bigger one. Yes, here there's an inductor here. Let me just raise a little bit. I know it might not be visible enough to you, but I'll just try my best. This one, you can see. Yes, and we have 0 resistance, so it means that inductor is good. What about this big one, which is located near the battery connector? Let's have a test at it. Let's have a look at it. This one, it should also have the same results. You can see this. Yes, 0 resistance. So it means that inductor is very good, and it's not open or it is not um, broken. Again, when you want to test whether there is a short along that line where that inductor is placed, you will still have your meter under the continuity within the continuity calibration, but you will now test against the ground. You will test against the ground. So I like us to use this this machine is it contain a casing, so it's consuming a lot of space in my table. So let's have a look at this one. Yes, I believe we had those inductors where here. These are the inductors. Okay, don't worry, because even if it is invisible to you, but I'll be explaining to you. As you can see, these inductors, this is a power lane. Along this power lane, we'll have a branch of power branching from this inductor. So meaning along this lane, as you can see, there's a track. This is a power track. This is a power lane. This a big track here, like a river. This is where the voltage flows through. Yes, even past here. At here, you will have inductors connecting this other point to the other point. So here, you will have inductors connecting the 2 points. Yes, you can see these are the inductors. And here, yes. In case I want to know whether this power line is connected to the ground, I'll just use my digital multimeter. place my probe to the ground, my black probe to the ground, or the red probe. It doesn't matter which probe you use because we are testing the continuity anyway. So no matter which probe you put at which side, it's still the same. Then I'll use my other probe to test the power line, whether they are shorted. As you can see this one, yes, this one, it means that lane is shorted. Why? Because I can see we have a very less resistance, that is 3.2. However, maybe not shorted, maybe shorted. But what you need to understand, in case we have zero resistance between this line, this power line to the ground, it means we have a short. But this resistance, which it peaks, yes, but you have 3.2 resistance. So that one means that line connects to the processor, or that is the main line for the CPU. So if you can follow clearly, this line probably connects to the processor. As you can see, it comes here. Before it branches to this other side, there's a branch going here towards here. And behind here, behind these very many capacitors here, we have the processor at the back. So what defines the short or the continuity and non-continuity is that resistance reading in the meter. So as you can see, these capacitors, you can see this other side, it has 3.2 resistance. But the other side, it should read 0, 0. To mean it is connected to the ground. See the other side, 0, 0, 0. So it means this other side is the ground, this other side is the positive line. However, it peeps. That peeping means that line is connected to the processor. It has the resistance from the CPU. So let's continue testing our theory. I said the line which when the power line is shorted, it should beep against the ground. So let's have a look at this is the main power line. So this is the main power line. As you can see, this one is not beeping against the ground. However, it contains the resistance. It has like 463 ohms. Same case with this one. It should not beep 77 ohms. Same case with this one. It should not beep 415 ohms. Why these inductors are not beeping? Because they are not connected to the ground. This is the power line. So when you test any inductor against the ground, it should not beep or it should not show less resistance, except when they are the inductors for the processor, like this one. So these are the power supply to the processor. So this one, I believe it will have a resistance. However, it will beep like as if they are shorted to the ground. You can see this one. You have 5.0 ohms resistance. So these three inductors, 1, 2, 3, it seems they are supplying, in fact, there are 4, 5, there are 5 inductors, all of them, they should have the same resistance. Why? Because probably they are supplying power to the same unit, especially maybe they are going for the CPU or they are for the PCH. So let's see the resistance for each and every one of them. You see 5.2. Oh, I'm so sorry. I thought you were saying, yes, let me place it this way. Yes, you can see this first inductor. Here at the top, it is written R12 936 VB8. Same case with this one, R12 936 VB8. R12 936 VB8. So all of them are the same except this one. This one is written R33. This one are off. So meaning these are different inductors. However, they are channeling their voltage towards the CPU, but probably they are supplying it to the PCH. But unlike his ones, they supply to the same, that is CPU, supply the voltage towards the CPU. So let's see the resistance for each and every inductor. This one, 5.3. This one, 5.3. This one, all of them should have the same resistance. This one is 3.5. So maybe there's something wrong with that. 3.5. However, so now as you can see, I have 3.5, 3.5. So meaning I can rule out. So meaning these two are the twins. This one are the twins. If this one supplies one voltage, maybe this one supplies 0.8 voltage because one of the supply goes to the core, to the core VCC core or VC core for the CPU. It supplies the voltage to internal components within the CPU. What about this one? Should be 3.5 again. So these three supply the same, it has the same resistance, meaning they connect to the same chipset. What about this smaller one? That one is 2.7, less resistance. This one have no resistance. Meaning what? Meaning this one is not supplying anything towards the processor, towards the CPU. So that's how you test for the inductors. Yes. When you test against the ground, don't expect to show if it is not for the CPU, if it is not the inductors which supplies the CPU or the GPU or the PCH or the solder bridge. If the inductor is not supplying either of those chipsets, you don't expect to have to PIP, and you don't expect to have less resistance, right? Yes. But if the inductors are supplying power away from those chipsets, maybe it's the power supplied to the RAM or the power supplied to the speaker or power supplied to the network card. Those coils or those inductors are not connected to the ground. So if you test them against the ground, it should not it should not pip it should not be pipping. At the same time, it should not be having a very low resistance. So it should have a very high resistance. For example, this one. Let's have a look at this. Let's have a look at this one. So this one, here, this motherboard, I can see we have some coils here. These are the, as you can see, this is the BL. Wherever you see a gold written L, that means that is an inductor. If it is BL, that's the power inductor. If it is just L, it means that's an inductor. PL1, for example, that is a power inductor 1. Yes, whenever you see anything labeled L, it means that is an inductor. So let's have a test. Let's test this one. So this one is the ground. So I can place my ground to any screw hole. Yeah, as you can see here, I have resistance, a lot of them, because that power supply is not supplying power to the processor in any way. What about this one? Still the same. You have resistance, infinite resistance. What about where? What about this one? 56 ohms. It's good. This one, I believe this one supplies the processor. You see? Yes, that's a resistance from the processor. This one from the processor. This one, and not going to the processor, and it doesn't have the short. This one, processor. Yes, whenever you see the some readings with the, in my meter, it means that point is not connected to the ground. This one, yes, I like to explain more about this. Yes, I can see this capacitor is cracked, so I don't know whether that one is playing about the short. You can see this inductor. You have an output of 0.7, so that's a very low resistance. So I don't know. Sorry for that. You can see this one. Yes, and my meter is off. So let me refresh it. Yes, ground against this inductor, I have 0.08. So it means I have a short. And that short, this is the line for 3.3. So probably that short is directly at the processor. Yes, I have a very less resistance. So it means there is a short within my processor, right? Yes. So guys, thank you so much. Let me believe at least you've learned how to test for a shorted power lane. So when you want to test for a shorted power lane, you use the inductors. You use the power supply inductors because those inductors are not connected to the ground. So whenever you test against the ground, whenever you see there's a continuity, it means that line is connected to the ground and should not be that way. It's not supposed to connect to the ground. So whenever you test it against the ground, if it is connected to the ground, it means you have a problem. Again, when you test the inductor against each other, yeah, you test side by side. in case you have some readings or it shows no continuation, no continuity between them, it means that inductor is broken, right? Yes. So thank you so much, guys. I believe so far we've learned something about the inductors, how to test the inductor. Uh, During my next video, I'll be showing you guys how to test for the resistors, because all of these components, it is important for all of us to know how to test them, so that whenever we are doing the motherboard diagnostic, you'll know how to test whether that component is faulty or not. Yes, step by step, we shall finish all the tutorials about the laptop repair. So thank you so much, guys, for being patient. I believe you've learned something, and we shall see each other in the next video. So please subscribe to this channel, share with your friends, and I'll be really very happy. Let's grow this family together. I know we still have a long way to go, but step by step, one step at a time. Still, in case you have a problem with your computer, or you know someone who has an issue with his or her laptop, please you can refer them to us. We are very friendly, so don't be afraid to send your laptop. We do our work professionally, so don't be scared or don't have any fear. Yes, we will try our best to. I know we might not repair your laptop, or we might repair. We'll try our best. I know we are not the manufacturers for this computer, so if we fail to help, there's always another time. Again, we do teach. In case you know someone who is interested in learning about laptop repair, you can still contact us, and we might be able to help. Not we might be able, we will help. We teach. So thank you so much, guys, and see you in the next video. Goodbye.